let's move now on the file system structure. So how is a file system organized in different layers? The idea when you design a file system is to have different layers for different functionalities. This is true for a file system, but I even mentioned this in the very beginning of the course for the entire operating system, that you can have different layers. It's good for modularity and keeping, let's say, different types of jobs in different levels and in different modules. So these are basically the different layers you can have in, if you want to organize your file system in, let's say, different parts. So you need the lowest one, so the one that is very close to the device, to be about I/O control, okay? You will need a part of the file system that is the one that actually speaks this kind of language, which is read a specific drive, maybe a specific cylinder and track. This is, of course, for allocating disk. It doesn't apply to an SSD, but it's the very low-level I/O layer that speaks basically the language of the device. On top of that, you have the basic file system, so-called basic file system. It speaks in terms of blocks, so it says retrieve a specific block or write to a specific block, and it's also the one that maintains buffers and caches when you read and write to the disk. These are similar in spirit to what we discussed also for the memory. You have the file organization module, okay, and this is about translating logical blocks into physical blocks. So if you want to read the fifth block of a file, again, to simplify the life of the programmer, the processes and so on, the operating system separates between logical and physical addresses. So from the logical perspective, the fifth block is the fifth block. It starts at 0, so it will be block number 4. But in practice, this block might be written in a disk in several positions. It's not, the disk is not going to use necessarily contiguous allocation, and I will present this in the next video. In this layer, you also have the managing of free space, so not only the translation between logical and physical, but also this is the layer that maintains information about where you can actually write if you need to write something new. And here, of course, you start having understanding of files and too, not only blocks, because of course you need to have the concept of a file in order to understand what is the logical block inside that file and translate that into the physical one. The highest level you have just before actually the applications that you run is the logical file system. This is where you keep all the metadata I introduced before, okay? And now this is what we are going to discuss next when we see at different ways of actually maintaining data files into the disk. Before that, I also want to mention that since you have this separation of functionalities in different layers, this is what allows you to have virtual file systems. So in practice, you can have different file systems that are maintained at the same time, and they can be implemented in different ways, maybe speaking to different type of devices and so on. Since you have the different layers, you can define also a layer that is the virtual file system, which does, once again, acts as a middleware, stays in between the lower level interfaces and the higher ones, the user, the processes, to translate commands like open a file, read a file, and so on from the general interface, the common shared interface with the user, to the specific ones you have for each file system. So the next thing we're going to look at in the next video is how we actually implement files, how do we keep them, okay? So if we have a disk block N on our device, how do we know what is the file that is contained on that block, okay? We will discuss 3 different ways, contiguous allocation, linked list allocation, also with the file allocation table variant, and inodes that are the ones you actually use, for example, in your Unix systems.